Hello, and welcome to another Project Catalyst conversation with me, Kim Clyden. Over the last decade, significant improvements to productivity and profitability in sugarcane have been made through the application of spatial data and adoption of zonal treatments. So why is the uptake of precision ag so low? According to Professor Andrew Robson, University of New England's Director of the Applied Agricultural Remote Sensing Centre, less than 20% of farmers on the planet have adopted PA to assist them in their farming operations. Considering technology like NDVI has been around since 1967, what's happened in the last 57 years? Professor Robson is passionate about improving outcomes for farmers and visits regional farming communities regularly to share his extensive knowledge and encourage farmers to adopt and apply the suite of remote sensing tools available. We sat down to explore spatial data, AI and the future following one of his presentations, where I gained an insight into where it all began.
I had excellent scientists as mentors that did agriculture because they loved agriculture. They loved to see science evaluated in the field to give the right answers and to help industry adopt this stuff and adopt it appropriately and to make sure it works under different situations. And so it wasn't about the sell, it wasn't about writing papers, it was all about how can we make things that help growers do what they need to do and answer problems that they face. And I suppose after nearly 20 years with the DPI system, that still holds dear, and it comes back to that great mentors of those senior scientists back through New South Wales and Queensland. So I think that's where it comes from. But I'm also a farmer myself now, so I also farm oysters, and I have done for the last 2 years with my own oyster farm. So I've gone through the transition of DPI to academia to now being a farmer. So I have all those bits and pieces now into place. And I suppose the last bit is I'm also the president of the Queensland Oyster Growers Association. So now even helping at that industry level to help herd the goats, herd the cats into making sure all these bits need. What do industries want? What are the technologies or the science that can possibly help it? And then how sure are we it's going to work? And then fit it all together.
So you weren't influenced by a family history in farming or being on the land at all?
No, I grew up all around Australia, grew up in Canberra predominantly, born in Melbourne, worked for a mining company in Darwin, picked fruit for a year in the Riverina when I was young. And so, yeah, I think 17 was my first sort of exposure, and that was picking fruit, and then went to rice and then everything else afterwards. So,
what did you actually study to become involved in this sector from the beginning?
Yeah, study's a good thing. I'm not a very true academic, even though I'm a professor, which is pretty hilarious. So I did environmental science and remote sensing right back in early days in Canberra. But when I started working with the DPI as a young casual on rice physiology, again, an older scientist I worked with said, you can do degrees by correspondence. And so I had two young kids, really young, had kids, so I was doing rice during the day, and then because Child Sturt offered that remote learning, I did my degree. So I was doing my degree at night and on weekends with the two young kids and doing rice. So I did it that way, and then completing that, I had to do my first presentation in 2000 in Hobart, and I was petrified, a young little scientist talking at an international conference. But two scientists from Kingaroy turned up. They said, we're really interested in remote sensing of peanuts. And so they offered me a PhD in Queensland DPI working on peanuts using remote sensing. So I did that, and then just it's grown now to 15 industries in 10 countries. So it's been quite an amazing progression, but nearly 30 years of doing it. So that's why sort of all the learning and learning, where I'm sitting now. So,
what is remote sensing?
It's the science of taking a measurement of something without actually touching it. So that's the remote bit, and the sensing can be anything from eyeballs looking at something and making evaluations to drones, satellites, standing next to it with a smartphone taking thermal pictures. That's remote sensing.
You mentioned a little bit earlier the early days of remote sensing. When was that?
Look, there was a lot of lab-based NIR work, so that's near infrared work, in laboratories right back in the 60s and probably even earlier. Landsat satellite went up in the end of the 60s, so that was the Earth observation Landsat sensor that was measuring stuff. It's sort of evolved over time. Some of the work I talked about today with the growers, looking at just crop health and high growth and low growth, and using near infrared and red bands and things like that. That's been around since 1970, or even earlier, but that applied stuff sort of 1970. So you're talking now 50 odd years. What's different now is it's evolved over time. There's a lot more satellites available that go over every day or every week. The amount of clarity of the picture is so much better, so you can see down to 1 metre or 30 centimetres as your minimum unit. The cost got a lot better. The computational to be able to process massive data sets and generate these mapping things have all evolved exponentially over the last few years. So now it's the applications are endless, and the practicality of adoption is a lot better.
So over the last 10 years, what changes have you directly witnessed in relation to using the data sets that are coming out of some of this technology?
Well, fundamentally, it's all about the application. So what we're looking at, things like a lot of industries don't know how big their industry is. So how many crops do we have growing? And is it moving in an area? Is there new areas being planted or lost? There's no space. There was very little spatial understanding of where crops are in Australia, down to that sort of individual farm level. So that's one thing. The other thing is be able to predict yield. So if you're as an industry or a grower, if you want to sell your product after harvest, if you can't predict early in the season how much yield you're going to have, then your forward selling or your marketing on how much you're going to sell is not there. And if you don't reach the amount that you promised, then you can damage your contract. Or similarly, if you overproduce, then you waste product because you can't get rid of it. So things like yield, biosecurity threats are growing all the time. So there's been a heap of range of increasing biosecurity threats for plants in Australia, with yellow canopy syndrome and cane smut and sugar. You've got citrus canker, and there's a whole range of things that seem to have high prevalence. So the use of remote sensing to better understand and prepare and added surveillance for these sort of things is really important. The other thing is natural disasters. We're getting our floods and cyclones and everything so much more now. So again, if we want to look at the impact of where these cyclones are hitting or where these severe weather events are hitting, and that includes droughts and bushfires, if you don't have an understanding of where the crops are, if you don't have an understanding of how healthy a crop was or the damage imposed by these events, you can't quantify it. You can't prepare for it. You can't respond to it. So all those applications over the last 10 years have increased. It sort of coincides with, if you talk about the technologies themselves, you've seen the booms in ag tech. So you had a big data boom for agriculture like 10 years ago, but then they realised there sort of wasn't really good high quality data for every single field that's all been quality assured that you can just run in a model and done it. So big data sort of went really exciting and not so achievable. Then it went to the drone boom, and drones are going to triple yield and they're so awesome, and I can do amazing things with drones. That went crazy, billions of dollars globally spent on drones, and many companies failed and so much money was lost. But out of that, there was a whole range of ones that actually came out as good applications. Okay, a drone will work really well for this, it's a nice platform for this, and they've succeeded. Now we're seeing the machine learning AI boom. So we've gone through these booms and waves, and they're really good for fast-tracking some technological advancements or analytical advancements. But there's also the negative side of it, which I'm quite vocal about. When you talk about passion of good things, that's where I get in a bit of trouble with. The rationale of a lot of companies for getting into this is to come up with an idea, which is nothing wrong with that, but it's to sell that for a huge amount of money for themselves and move on. And it doesn't come into factor that potentially an industry's got really excited about that idea and you don't follow through with it. So you just sell it and move on, you made your money, that's fine. And good luck, that's good, that's a model that works. But we are, as a byproduct of that, we're seeing grower fatigue, we're seeing industry fatigues. They've gone, okay, well, you've promised this, you didn't deliver this. You promised this, you didn't deliver this. You promised this, didn't deliver this. And so now they're sort of sort of a static flow of saying we want this stuff, but we want it provided. We want to know what we can do with it, what's been tested and what's been calibrated, and what we can rely on, and we want it delivered in a way that's affordable and practical to adopt. And that's where we're in that really good spot at the moment, where we can better integrate industry need to technological development and then commercialisation. So the three coming together to provide the whole flow. That's where I think after this big 10-year boom of everything has been, is sitting at the moment, and we can do that a lot better, and that's the way forward.
Well, you mentioned in there that a lot of the data applications are being used for forecast projections of yield and money that can be made, because a lot of our resources are commodified.
Yep.
The Australian ag sector is forecast to contribute $85 billion in the economy in the 24-25 financial year. Conversely, how has the development of spatial data contributed to the increases in productivity and profitability for the industries?
Yeah, that's a big question.
It was a long question.
There is definitely changing climate, so understanding how crops are performing now in current day to how they did 5 years ago, 10 years ago, 20 years ago. Is it time that we start looking at either changing farming systems in different regions that are more resilient or more productive in these changing climates? Or do we relocate those to other regions that are now hitting those sort of climatic ideal zones that they could be placed now?
Well, specifically for sugar, because we've been working with Project Catalyst for the last 15 years, and those guys have made definite improvements in their sustainability, productivity and profitability through the adoption of a lot of these technologies, minimising inputs and increasing yield output.
The best thing about remote sensing and spatial analytics is understanding variability, whether it's at a region, a farm or a block level. What is performing well, what is not performing well. That allows you to go in as a grower or an industry to work out what's driving that. Is it soils, is it nutrition, is it pest and disease? Therefore, if I identify what's driving that, you can target your inputs. So if it's a nutrition thing, we put nitrogen per se in this area as a high performing area, and we get more production out of it. And areas that aren't performing, we don't put any more on it because we're just wasting it. Now the byproduct of that means you're using inputs a lot more smarter, so using less input, which is causing, resulting in less cost for growers, but also less potential runoff and environmental issues with over application of nitrogen. But you're not forsaking productivity because you've gone through that process to work out, well, there's no point putting nitrogen in that area because it's not going to respond. It's got other issues, sedicity or something going on. So don't waste it. So that's the difference between just treating your farm as one unit and saying, I'm just going to put all this nitrogen on because my dad did it, my grandfather did it, and my grandfather did it. So that changing of mentality is a really good demonstration, and it's the fundamental of precision ag that has been there for 20 years or more. So it's not anything special we're doing. It's more, it's just better adoption, because the adoption of this stuff still remains really low. It's still below 20% globally. So there's something that we can all do better to try and to bridge that gap.
Through your line of work, what have you identified as one of the blocks or challenges in people adopting this technology when it's so proven?
Well, it's a whole range of things. Accessibility of information is one. So if it's not provided in a way that's cost effective to access, so if it's too much compared to the benefit you're going to get out of it, then straight away you wouldn't pay for it and then get it. The next is the way it's provided. So if it's not accessible easily, and the example like I did in the talks is the bomb radar on your phone these days. If you want to know a storm's coming, you just go, boom, show me the radar, you look at it, and it's so simple. Everyone uses it because it's so simple. That's a great demonstration of something that works really well. But if you have to go and log in and try and work out spreadsheets or platforms or dashboards, and you've got to enter a heap of data and stuff like that, on top of everything else, whilst it has benefit, it's a pain. And it's time difficult. It's difficult to navigate your way around it, and if it doesn't work or it fails during the process, that's it, you shelve it. It's a bit like if you go and buy a drone again and you fly it for the first time and A, it doesn't connect with data, or B, it crashes after 10 minutes, you go, that's too hard, and you're going to throw it in the shed. So there are two things. One's cost, one is the delivery. The third thing is, if it's not tested and validated and you believed that it's going to do what you got told or sold it was going to do, and it doesn't, you're straight away off the technology unfairly. And so you, as a grower, could go around to other growers and say, no, I've tried that, it doesn't work, it's crap. Oh, it doesn't work, sorry, I shouldn't say that.
I said shit, so crap's fine.
Sorry, then you run the problem of distrust in the products, and also fatigue, that you've seen it once, you don't want to see it again. And that's the bits that we're missing out on. And that's where we've got to be really careful that what is put out there is properly validated and calibrated, and it's delivered in a way that's adoptable. And I think we all generally want to achieve that, but we just got to do it better.
In relation to investment and costs, ongoing as this technology continues to develop, can you see it being more affordable and more adoptable?
Oh, definitely. If you talk about satellites, the provision or the launches of something like a Sentinel satellite, which is from the European Space Agency, which was 2016, that goes over every 5 days. It's 10 metres by 10 metre pixel size, so your minimum unit. It's fantastic for looking at variation in healthy and unhealthy parts of your crop or your farm or your regions. It's a really reliable satellite as an example of one of many, but it's freely accessible. And so you straight away, you've got a good product that's reliable, telling you what you want to know at a scale you want to know and can respond to, but it's freely available. So what you need now is actually the science of what can you do with that information, what is it going to tell you other than just this is healthy or this is sick. Like, is it a disease? Can you predict yield? Can you predict quality? Is it a soil issue? Is it a nitrogen issue? All that research, which has been years and years of that for a whole heap of groups. And then again, how to access it. So I think that answers your question, maybe.
So recently we did an interview with Tony Bajaya, one of our growers, and Zoe from Pharmacists.
Yes.
And the story that they told was a very interesting one, and one that I hadn't heard before in relation to how spatial data can be used together as a whole picture when something else failed. So, and not so much failed, but the yield data that was being generated by a new yield monitor on a harvester wasn't really substantial enough for Zoe to use to predict, what ameliorants should be applied, for instance, in a paddock. So, I mean, is that something you guys are working on as to how all those different data sets can be used together?
Yeah, definitely, and that's been 20 years of work with cane, and that started off with collaborating with Cyro, who were doing some yield monitor work, in cane. This is 20 years ago. Is showing that you can get a good relationship between, a working, trustworthy, harvest monitor on a commercial harvester at, every metre doing a measure of yield versus one that's generated from satellite imagery. So you get the zonal differences the same as long as things like speed and all that stuff is accounted for. But if you're getting a metre resolution from this commercial harvester, are you as a grower going to manage your crop at that metre by metre by metre? Like, are you going to go in and change your inputs at that metre by metre scale? And, talking to growers and for years and years, they don't. The smaller scale they're generally interested in, unless it's like a disease or potentially cane grubs or something like that, is that zonal differences. They want to know within their paddock or across their farm, what are the high growing and low growing and medium growing zones or areas. That's the area to target. And even that's a mission to do that. But they're not going to manage individual plants. It just doesn't happen. There's no benefit of why you would do that. So I think that's the balance.
What further gains can be made in the next, say, 5 to 10 years in relation to applied agricultural remote sensing and the way those spatial data sets can be utilised, particularly in big industries like sugarcane and broadacre?
Well, it's the integration of technologies that you mentioned before. So I mentioned before that one of the things that's not only we do but other groups do as well is mapping commodity locations, so crop locations. So first of all, you've got a layer that shows where all the crops are. Then you can go back and you look at current imagery and historic imagery and work out historically how do these regions, how do these farms, how do these blocks respond over time? Where are they sitting? How should they, irrespective of management or weather, where do they sit as a benchmark? So if you suddenly have an impact of pest, disease, biosecurity threat or other, you can immediately go, righto, we know where the crops are, we know where it should be sitting at this time of the year, it's doing something totally different. As a warning system, something is happening. It could be climate driven, it could be natural disaster, but we need to go in and look, they're moving outside of that realm. So that's one thing. The other thing is the weather information provides a lot of good inputs as well in terms of quality and drivers and things like that. Is the positioning of sensors appropriately? Like there's been a lot of push of Internet of Things over the years, but it's totally unfeasible to put a sensor every 100 metres on your farm. It costs too much. They're totally, well, not totally, but they're generally quite unreliable in agricultural settings, and that's not only their robustness in outside environments, but rats eat them, foxes eat them, crows take the sensors. Data connectivity is a big issue still. So it's how do we appropriately place these in single point locations that are more representative of a bigger area. So you can use, again, remote sensing to work out where are historically high performing areas of a region and low, or even down to the farm level. Let's put a sensor there and a sensor there. And now that one point represents a bigger area. And so zonally. So bringing that information together, and it's collating all these different technologies into, again, the application. How do we fit it all together? And I think that's got a lot of space to play into the future. We stop the sort of focusing on the technology, but more what is the application and how do we bring the expertise and the technologies and even the marketing and selling and the provision of this together to answer those things.
University of New England's also has the smart farming component of agriculture, and we actually had David Lamb present in 2017. What's the next for remote sensoring and robotic technology when it comes to integration, which we were just discussing?
Yeah, first question about Smart Farm. It was one of the first in Australia, and now there's the Smarter Farm and the Smartest Farm, and there's all these little smart farms popping up. I think the potential is they serve as a very good test bed to bring some emerging technologies together under a real farming situation. To do that first evaluation of how it works, how reliable it is. And I think that's evolved better over time as more smart farms are coming up. So I think as a research place to do that sort of stuff, that's where they serve their purpose. The ability to extrapolate findings from them from a location or a farm is challenging because every farm's different. And if you go to different areas, there's different soils, different slopes, different varieties, all sorts of things, climatic conditions. To extrapolate in its exactness, what you measured on that smart farm is really difficult. So it's more as I said, concept development. For robotics, there's some really good operators. So we did a lot of work with Sydney Uni, who evaluated the use of robotics and robotic sensors for tree crops. And that subsequently spun off to a company called Green Atlas, championed by a good Australian researcher who now does, it goes around the world. It's been adopted anywhere. But the really cool thing about that is not only did they have the fundamental, really good core science to work out all the image analytics and all that associated with the sensors, they've transitioned it to how do we make this or deliver this in really low-cost sensors, and how can we get rid of, in this case, get rid of the robot and put the sensors on a quad bike or on a tractor. So it's taking that really high-end learning and how do we apply it in an adoptable, affordable and reliable way. So I've got a lot of time for these guys because they have gone through that process. It wasn't just, again, I can sell a drone, so therefore it's awesome. It's the fundamental science, engagement with the industry to demonstrate it, and then how do we package it. So that's a really good example. The other thing is, look, robotics in general or running a robotic machine is quite difficult in Australia. I don't know if it's changed, but historically it was actually, you weren't allowed to run a fully autonomous thing without control of it. Like you either had to be physically watching it with a kill switch to kill it if it did, or be sitting on it. So legally, and again it might have changed, but legally you weren't actually allowed to do it. It was slave or master, so you could drive something that was controlling the one behind it. Also, cost is a big issue. So again, back to that cost benefit, is the cost of putting this thing in your paddock, I mean that's not derogatory, I mean like whether it's
an autonomous vehicle or robotic.
Yeah, whatever it is in your field, is the cost of getting that in there worth the possible benefit it's going to provide you, the cost benefit at the end? If it does, then great, look at it. If it doesn't, then you've got to weigh up, well, how can I do this as a compromise between that and something else?
Probably collaboratively, like a lot of our farmers are saying that maybe they need to get it at a community level where they've shared harvesters and implements before to innovate, and maybe that's the next step. So everyone can share it because they work 24/7, they'll work Christmas Day, they'll work whatever. But like you said, there must have been some change to the law, because that's one part with the autonomous tractors. I know specifically the government has not changed its view on allowing them to operate in Australia, according to the big companies. Robotics, maybe because they're a smaller machine, they are being adopted, and Roboti is one of those that I've seen coming into Bundaberg, and is now being employed by Jamie Jurgens at VJK in Bowen. And he has a robotic planting, weeding tool that's been taken around and showcased since last year. So, there are some interesting... It's all happening in Europe. Why is Europe leading when Australia is such a huge continent and dominated by agriculture?
Well, look, Australia's generally really good in the development of ag tech, first of all, because we're subject to such extreme drivers of variability, climate and water and pest disease and even scale. We have to do that, let's say autonomous steering is one that came out of Australia that now is most adopted around the world. I think we've done a lot in it over a lot of years. So there's been a lot of remote sensing for years by many groups, not just us, but many groups. And with robotics, it's evolved over time as well. And again, there's quite a lot of groups, and now AI. There's a lot of groups doing AI. Why is Europe doing it more?
Money?
Well, could be. It could be. Like, I know a lot of the ag tech companies looking for big money will try the US system, or they'll modify their delivery from it, rather than agriculture, will look at something else that's topical at the moment, like carbon, and so they'll pivot and pick a topic that may attract money. But agriculture in Australia, we're really good at doing it, but I think one bit where we maybe fall short is the commercialisation, or that final step. So you look at universities, you look at a whole range of things. We do all the science, we like what I've been showing over the last couple of field workshops. You show this stuff, it works extremely well. Now, how do we get this in a package that's really adoptable? And I showed the rice example. It's working really nicely at the moment through Sunrise, where it's a nice platform and all growers can access it because Sunrise are driving it and they're behind it and they're saying we need this. So therefore, through a funding agency, they are doing this. It's getting better, but I think that's the missing bit. It's a hard one to answer. But you look, so we do avocado forecasting, and Australia produces 1% of the world's avocados. We've just got contracts now to do 6 countries with the biggest avocado producer in the world, and also other countries through separate ones, because our methodology developed in a little group with Australian funding from the Australian industry has proved to be the best methodology, or proving to be the best methodology for yield forecasting avocado anywhere in the world. So we're getting trial by all these different groups, and it's succeeding. It's providing really high accuracy and saying, right, we'll contract you to do that. And so it is happening. As long as the research is, as long as it's been tested to be robust, as long as you can stand behind examples and you can get, to refer them to other industry people and say, are you happy to talk about your experience with this? And if they are happy with it, then yes, this worked really well. As long as you've got those examples, then it will be adopted around the place.
So it's farmer-led?
For us, it is.
Peer-to-peer?
Yeah, look, we like many, have gone through the battle of where you try and provide it as, or you develop this stuff as an academic or a government outcome, and extrapolating that to industry is difficult. Then we tried, dealing grower by grower and building all our information and trying to work that model, and it's very hard because there's a lot of personalities, a lot of different needs in the way delivery is, the understanding of what you're doing. So the way we do it is work with industry bodies or mills or productivity services. So it's an entity that you're dealing with that then disseminate the information through their grower base. That way it's a common theme, a common problem you're addressing, and the delivery is in a much standardised format that this group now is responsible as part of their agronomic service to provide. And I think that model is working a lot better. So when I talk about the work we're doing overseas in all around the world in all these different crops now, they're predominantly with the industry bodies or big companies as a delivery for all their growing. And that's a way that's working really well.
Andrew Robson, it's been a pleasure picking your brain today. Thank you so much.
No worries, thanks for the chat.
Thanks for spending time with me, Kim Clyden, in conversation with Andrew Robson, the Director of the Applied Agricultural Remote Sensing Centre at the University of New England. For more stories about Project Catalyst and the people inspiring change, please go to our website, projectcatalyst.net.au, and social media channels. You'll find us on YouTube, Facebook and LinkedIn. Project Catalyst is funded by the partnership between the Australian Government's Reef Trust and the Great Barrier Reef Foundation, and the Coca-Cola Foundation with support from WWF Australia.